Good evening and welcome to the University of Reading and to this evening's public lecture. My name is Professor Dominic Zahm. I'm the Pro Vice Chancellor for Research and Innovation, and it's my great pleasure to welcome you all here tonight and to introduce this evening's lecture, which is an experiment in interdisciplinarity, bringing together metrology and history in an unusual but fascinating combination. For those regulars in the audience, welcome back. For those who are here for the first time, welcome. And a special welcome to colleagues and friends from the Royal Military Academy at Sandhurst who are here this evening as well. I'm delighted to introduce this third in our lecture series in this year, 2018-2019, Space Blitz, Discovering the Hidden Impacts of the World War II bombing rates, given by Professor Chris Scott and Professor Patrick Major. It's an especially apt topic given that this month we are marking the 74th anniversary of the Dresden bombings. Strategic bombing, the bombing not of concentrations of troops, of military fortifications or supply lines, but of cities and of civilian infrastructure, probably changed the nature and the experience of war more than any other military development in the last few centuries. While the violence of war has always been experienced by civilians as well as by soldiers, the development of air power and the capacity to deliver bombs far behind the front line dramatically changed how ordinary people, hundreds of miles away from the front, experienced war. Warsaw, Rotterdam, London, Dresden, Hamburg, the list could be extended, and the bombing of all of these cities has become part of the collective memory of the Second World War in the respective countries. It meant that the experience and the consequences of bombing raids coexisted with and became inextricably linked with everyday life. Images of families having tea next to smoldering ruins, children being born in air raid shelters, blacked out windows, curfews and evacuation routines once the sirens wailed. So coinciding with the anniversary of the British raid on Dresden, historian Patrick Major and space scientist Chris Scott will explore two very different perspectives on the Second World War bombing raids. First, Patrick will give us a perspective from the ground, reconstructing from the archival materials how the bombing was experienced and the terror of the bombing was experienced on the ground. And then Chris, in between, will zoom out into space and show how he and colleagues at Reading, through conducting an experiment of the past, using the archival data and bringing it together with their space observation data, shows how the blast waves from the bombs not just shook the ground where they fell, but literally shook the edge of space. So before I pass on to our two speakers to take us on this journey, let me briefly introduce both of them. Chris Scott is a professor of space and atmospheric physics here at the Department of Meteorology. He gained his PhD at the University of Southampton, where he studied the Northern Lights, the aurora, after which he worked at the Rutherford Appleton Laboratories, amongst other things running the UK's Ionospheric monitoring program and working as a project scientist for the UK cameras on board of the NASA Stereo mission. He joined Reading in 2010, where he is now Professor of Space and Atmospheric Physics. He's a fantastic science communicator and enjoys engaging around to science with wide and diverse audiences. He has made several appearances on the BBC's The Sky at Night, advising Brian Cox on the 7 Wonders of the Solar System, and once danced on the piano at the BBC's Tomorrow's World. But that isn't happening tonight, as far as I know. So the show was soon cancelled afterwards, apparently. But there will be another lecture after this. Patrick Major is Professor of Modern History in the Department of History here at Reading. He joined us in 2008 from the University of Warwick, and he got to know Berlin, which is the focus of his comments today, while teaching at the French school there in the 1980s, and he has visited ever since, including annual trips with our students to the city. He wrote Behind the Berlin Wall in 2010, and has a strong interest not just in strategic bombing, but also Hollywood perceptions of Germany, including a recent publication on the 1951 film about General Rommel, the Desert Fox. And he is currently working on a book, Blitz on Berlin, the Anglo-American bombings of Hitler's capital, which informs today's comments. Before I hand over to our speakers, just a couple of points. They're all here on the board, so I shall not repeat them, about phones being put on silent, fire alarms please leave the building as there are no tests. If you're an avid Twitterer, please join the debate tonight and tweet about the event under hashtag #YourOurLectures. Enough for me. It's my great pleasure to hand over to tonight's speakers, Professor Chris Scott and Patrick Mater.
Right, thank you. Right, okay, I'm the historian. 6 months ago, I knew absolutely nothing about the ionosphere or about space. But after this very intriguing collaboration in October, I found myself being dragged onto Radio 4's Inside Science, talking to the World Service about the ionosphere. So it's been a fantastic learning experience. And normally when we talk about interdisciplinarity from history, we might be talking about a language department, but not meteorology on the other side of the campus. So what you will find is that it was this strange combination which came together. But I'm going to talk a bit about if you like, what historians know about the Blitz, or perhaps what most of our perceptions are. As Dominic has said, this is a new type of warfare where civilian populations were being bombed. And we're perhaps all familiar with Coventry on the 14th and 15th of November 1940. Coventry was hit by several hundred Luftwaffe planes, and over 500 Britons were killed and about 1,000 injured. So when I was at Warwick, I worked for 17 years at the edge of Coventry, and you could still see the scars that were left of that. But other British towns had been hit very hard too. Perhaps the most bombed city in Britain was Hull, which you can see on the right. That tower you can see in the middle wasn't originally a tower, it was just part of a much larger building, the rest of which has collapsed. But I went to school in Hull, so I seem to have this sort of thing about being in very badly bombed cities. So I could kind of feel a little bit maybe of what had happened to the Germans too. But I think it's a painful memory in part of our own history, but in terms of what the Germans experienced, as Bomber Harris said in 1942, they sowed the wind and now they're going to reap the whirlwind. And, they certainly did get it paid back, maybe 10 times. So as we are also aware of the 74th anniversary of Dresden, what you can see on the left is actually the sort of view that the RAF would have had through the planning of these raids. So these are the types of route maps which are shown. If this is going to point it the right way. You can see this is the way that the planes are coming in. Every time you see a little flag, this is where there's an encounter with the Luftwaffe. But this was very late in the war. So this was really just about 2.5 months before the end of the war. Controversial in many ways, despite some of the justification that it was to help the Russians who were coming in. But because the British bombed at night on the 13th to the 14th, and then the Americans came in the next day, and through a kind of a fortuitous set of weather conditions and the fact that they actually concentrated the incendiary bombs, so the real killers in the case of Dresden were these small bundles of incendiary bombs. So this was from a reconnaissance photo the next day, and you can see this is what the Americans shot, that there are still fires burning in Dresden. So maybe 26,000 people died in Dresden just in that one raid, in a city which had hardly been hit before. So all told, we don't quite know the total casualties, but between 400 and 600,000 Germans die in aerial raids in World War II. British casualties are about 60,000. It's about the same as Italy and France. But I think that statistics don't really tell the whole story. But
RAF heavy bombers assist Marshal Conyers' drive into the Rush. The being used to pump German troops into counterattacks against the Russian army not many miles to the east. This strike put a stop to that. The night sky is pitted with aircraft, vari-coloured target markers, and the newest German attack device, a scarecrow designed to burst and look like a plane exploding after a direct hit. Static electrical discharge caused by intense cold mars these magnificent bombing shots. The day after the RAF strike at Dresden, these 17 bombers of the 8th United States Air Force gave the city a repeat performance. After these attacks, the German overseas news agency said, "This city, hitherto almost untouched, has been carpeted by heavy and super heavy high explosives and incendiaries. Dresden is a heap of ruins. It has been smashed to atoms." Before these attacks, Dresden was planned as a substitute capital in place of Berlin. After this, Hitler will have to look for a substitute for the substitute.
Right, so that's very much the kind of the public view that the British public would have got through Pathway News. It's the view, from above. Clearly, Dresden was controversial. I'm not going to talk about it much more in the lecture, but I'd be more than happy to talk about it in Q&A because it clearly unleashed a kind of miniature controversy within the RAF leadership. One of the things that you'll find at the National Archives, the physically heaviest files that I've ever encountered are these enormous so-called blue books. They're these albums which Arthur Harris collected, where he would have photographs taken of the 60 biggest cities in Germany, and then an acetate overlay, which would be coloured in blue, would show you the destruction that was going on below. So this is the Dresden picture, and you can see that large areas of the inner city here have burnt. And Dresden was a relatively old city, unlike Berlin, which I've been doing a lot of studying. It burnt much more readily. Where I perhaps first started thinking about what the bombing on the ground meant to Germans was when I was actually living in Berlin in the 1990s, working on a book on the Berlin Wall. It was much more about the Cold War. But at the time, I was living briefly in this building here in Schöneberg. This is a map which the German authorities did, a kind of a Schadenskarte, damage map. So red means completely destroyed, blue means really has to be demolished, green means perhaps reparable. And this map is this. So this is a gasometer, which you can see here, which has since been destroyed. But I remember at the time I was living in a family which had two children, two boys, Joscha and Kali, who were about the same age as my kids are now. And we were looking at this picture in a book of Berlin, and they were trying to understand. First of all, they couldn't understand, where was all this destruction? Because clearly things look different now. Some of the gaps have been filled in, rebuilt, but there were still things missing, so this was missing. And I suppose part of my research is to try and answer some of those questions about why we did this to this particular city. That Berlin was raided about 300 times during the war, whereas so far more than London in the end. I think no other city had as many raids on it. So it's remarkable how much of Berlin how many Berliners survived towards the end of the war. About 40,000 Berliners were killed. Now, so what my final bit, I think, where I'm going to try and explain what it looked like, was to show you a bit of footage which the Americans, as soon as they'd come into their sector in July 1945, shot in very high quality colour. And while that's playing, I'm going to just read you a little bit of a report of one bombing raid. A large number of explosive bombs fell in the vicinity, and one large one, thought to be nearly 2 tons in weight, fell in the embassy grounds. missing the embassy house and air raid shelter by a distance of only 2 meters each. As a result, the embassy house received what was little different from a direct hit, and the interior of the chancellery received damage which virtually amounts to complete destruction. The embassy is considered to be beyond repair. 90% of the fittings, furniture and the like have been destroyed. Numerous incendiaries and yellow phosphorus bombs fell, and fire broke out on the 2nd floor. But by the exertions of the staff and employees, the fires were contained to these areas. This was actually the Japanese ambassador explaining what had happened. And the reason we knew this was one of the Enigma decrypts. So through Ultra, Bletchley Park was listening in to the Japanese, who were giving these very helpful descriptions of what each raid was doing. Because often we could not see through the clouds. It took till about March 1944, about 3 or 4 months after the initial bombing of Berlin, what was happening. What you see here is one of the most infamous buildings in Berlin, the Sportpalast, where various propaganda speeches were held, including by Joseph Goebbels in February 1943, "Do you want total war?" And what you see here is that this building itself has become a victim of total war. So, by the end of the war, there was enough rubble in Berlin to have built a new Munich just from the rubble. So at this point, I'm going to hand over to Chris. Do you want this?
Yeah, go on, let's have a pointer.
It's quite good fun.
Thanks, Patrick. Well, meanwhile, over at the other side in the UK, I was really interested in this data from this particular research station. This is the radio research station at Ditton Park near Slough, and it later became known as the Appleton Lab. That merged with the Rutherford Lab, so it still continues today as one of the departments at the Rutherford Appleton Laboratory in Oxfordshire. But this was a radio research station. Radio, remember, around the turn of the 20th century was a really important new technological advance. It was being used for long-distance communications. And so this research station was set up to try and understand why radio reception conditions varied over time. And it's this marvelously quirky set of buildings. I think it's stereotypically how you'd imagine government scientists to be working, sitting in little sheds with peculiar aerials on them. There's a million pictures of, there's even one experiment where the shed was hoisted into the air so that it wasn't in contact with the ground. But there's one hut at the back here that was making measurements of the Earth's ionosphere. And this was a series of measurements that was started by Edward Appleton in the early 1930s. Now, Appleton was using this. Oh no, I should also say that there's another experiment which was tracking storms, and this was under the guidance of Robert Watson Watt, who later was knighted for his work in developing radar. But this was a portable piece of apparatus. I think you'll agree. It's slung between two burly chaps here, what this is doing is it's looking for the radio signals given off by lightning. Whenever there's a lightning stroke, it gives off a broadband radio crackle. And so by having a piece of apparatus such as this, or if you wanted to make it a field station, you could, oh, hang on, I'm going all wrong here. You could stick it on a table. And if you wanted it to be portable, you could put it on wheels. There was no end to their inventiveness here. But by listening out to these radio crackles and working out which direction that they were loudest in, you could actually track thunderstorms. And this was a real innovation. You could actually work out where these thunderstorms were and what direction that they were moving in. And so they were able to do this and produce charts like this, which is the bearing here. And you can see each of these dots represents a certain strength of signal. And so they were actually working out here on this occasion that there was a thunderstorm over in this direction. Now, as a lecturer, we're always telling our students you must label your axes and you must use units. And this is one of my favorite set of axes. It goes from small, medium, big, and very big. So this is how the earliest storm tracking was done. But Edward Appleton was also sounding the ionosphere. And the way he was doing this, I should say the ionosphere is the electrified layers at the very edge of space in the Earth's upper atmosphere. And it's ionized when X-rays and ultraviolet light from the sun hit the gas there and knock electrons off the atoms and creating this ionization. But it just so happens that those electrons absorb radio waves in the shortwave radio frequency. So this is why shortwave is so useful. So if you can broadcast a sequence of radio pulses here, then they will resonate with the electrons in the atmosphere, and they will reflect or certainly return the signal back to the ground if that radio signal exactly matches the frequency with which these electrons wants to wobble around. And that frequency is dependent on the number of them. So the stronger your layer gets, the higher the radio frequency it can reflect. So if you can imagine your apparatus here, you're broadcasting here on 1 megahertz, and it gets reflected from this layer here, this part of the layer here. You broadcast another pulse at 2 megahertz, gets reflected from a little bit higher up, 3 and 4, and that's the peak of the layer. Anything higher than that is going to go straight out into space. So by having an apparatus which they could send pulses of different frequency radio waves up into the atmosphere, and timing how long it took for them to be reflected, they could build up a picture of the ionization above our heads. And here is a resulting graph. They would store these on photographic paper, which was fed with a big clockwork device in front of an oscilloscope screen that was showing these things. So here is the ground, and here each one of these I think is 50 kilometers in altitude. So this is the first layer, the E layer, then this is the F layer here. So the various different layers and then double reflections and the like. But this was recorded here at 8:30 on the 8th of September 1940. This is the morning after the beginning of the London Blitz. So this is keep calm and carry on personified, I think. There are many hundreds of thousands of these records. They're currently stored at the Rutherford Appleton Laboratory. And Matthew Wild, the current director of the World Data Centre at the UK Solar Systems Data Centre as it is now, has brought some of those original soundings here for us to see. So if you wanted to look at these after the lecture, please come and have a look. You can actually see these are original recordings taken from the Second World War. But just to demonstrate what this is the layers that these are being reflected off, and the F2 layer, the very biggest layer in the ionosphere, that is at around a height of about 200 miles, about 250, 300 kilometers, well into space. If you were an astronaut, you earn your wings at an altitude of 60 miles, something like that. It's 100 kilometers. So we're talking, the International Space Station here is well within the ionosphere. So these are soundings from space in the 1940s. But they're quite complicated graphs. This is a modern digital version. We're still, as I say, these records are still being taken up at Rutherford, and this is a sister station from Norway. But in order to try and take a complicated graph like that and reduce it to a table of numbers, because remember back in the 1940s there were no computers to be able to deal with all these data points that were getting reflected, what they would do is they would say, okay, well, what's the height of each layer? Height of E, height of F1, height of F2, and what's the highest frequency that we can reflect off each of these layers? And that tells you how strong the layer is. So by looking here at this parameter, which was their favorite because it showed the very strongest layer in the ionosphere, how that varied with time, that gave them some clues as to what radio frequencies they should be using if they wanted to reflect their radio waves off the ionosphere and not use a frequency that was unsuitable and that would just go shooting off into space. So here's the standard plot of such things. So here's the Slough data here, and we're comparing it with the sunspot number. This is the number of sunspots that you can see on the visible disk of the sun. And it had been long known for hundreds of years that the sun has an 11-year activity cycle. So when the sun is very active, it's brighter in these wavelengths that generate the ionization, and so the ionosphere is that much stronger. You've got more ionization. So you need to know what state of activity the sun is in, but you can see that the F2 layer, which is this blue line here, follows that very, very faithfully. The sun is controlling what's going on. And you can see superimposed on that the annual variation, because we're going around the sun and the Slough is tipping towards and away from the sun through the seasons. And this is the second longest sequence. Slough now represents the longest continuous sequence of ionospheric data in the world. And Port Stanley in the Falkland Islands is in the southern hemisphere. It's one of the longest sequences in the southern hemisphere. There was a small break here in the early 1980s when somebody shot it with a rocket-propelled grenade. But we have a much better understanding of the long-term variations of the ionosphere now. But each one of these data points is a monthly average. So all of the variability in this is smoothed out to show you these long-term sequences. And the ionosphere is a lot more variable than scientists in the 1940s could understand. And so they assumed, they knew that it was down to the sunspots here, but they couldn't go into space to measure directly the X-rays coming off the sun. They were getting absorbed in our upper atmosphere. They don't reach the ground, but that was the assumption. And we now know, by all the modern spacecraft that we have, the beautiful animation of the sun in extreme ultraviolet light taken from the Solar Dynamics Observatory, that the sun does vary. It rotates about once every 27 days, and there are features which are very, very bright and giving off lots of ionizing radiation, and features that are very dark. And so as the sun rotates, we know that there is this variability. But we know exactly now, we can pinpoint, we've got very accurate measurements of how the sun varies, and this still doesn't explain the variability we see in the ionosphere. Something else is making it wobble. It's not just the sun from the outside, there's something else going on. And so the thoughts are that this must be coming up from below. So here's a shot from the International Space Station looking down at the Earth. Each one of these flashes is a lightning flash. So is there something? Is the activity from thunderstorms, from volcanoes, from earthquakes coming up from below having an effect? And some work I did about 10, 15 years ago now showed that under thunderstorms, certain layers of the ionosphere were enhanced. And so the thing we don't know is, was that some electrical signal going up into the ionosphere and ionizing it? Or was it some sort of shock wave being given off by the thunderstorm that caused the variability? So what I wanted to do was try and find a source of explosions that didn't have any lightning associated with them. And so Slough's quite near London, and I thought, well, okay, the London Blitz, that's got lots of explosions. I've heard of that. So how could these have contributed to the variability we see in the ionosphere? Now, the London Blitz started on the 7th of September 1940, and there followed 57 days of continuous bombing. The whole Blitz went on for about 8 months, and it killed 43,000 people. And here's a picture which is just quite shocking to a modern eye. It's a German aircraft over a very familiar London landmark. Now, at this point, I should make it clear that I'm not just ignoring the human aspects of the Blitz. I'm aware of how tragic the whole events were. My family lived in London. I can never get through this without choking up, I'm afraid. This is a photograph that my mother has that was taken by her sister, who was an air raid warden. I'm sure she shouldn't have taken it, actually. But this shows the searchlights over London. It also shows the tracer bullets going up to try and intercept the aircraft. And here is my aunt with my mother on her lap. And it's harder when there's lots of people in the room. This is her sisters, Janet and Shirley. And this was taken 2 weeks before this happened. So Janet and Shirley were killed with a stray bomb which landed in the garden and buried them alive. So I'm going to talk dispassionately about the data now. But please don't think I'm not aware that there are human consequences to these numbers. So this is the period in 1940, which we're looking now at the measurements made at Slough of this parameter FOF2, which is the highest radio frequency you can reflect from the ionosphere. And these two red lines represent the start and end of that 57-day continuous period of bombing. And to the first eye, you look at that and you think, my goodness, you know, the bombing starts here and suddenly this variability gets much, much bigger. But the problem is there is no control day. There is no day when the Luftwaffe stopped for you to compare it with and say, okay, well, it wasn't quite so variable then. So what you have to do is to look for other years when the solar activity is more or less the same and look to see if it varies beyond that. So here's a measure of the wobbliness of the ionosphere. It's the standard deviation of these figures. So the bigger this number, the more variable the ionosphere is. And you can see that for these various years, the red year here is the 1940 year, the year of the Blitz. And between these two red lines, again, is the time that 57-day period occurred. And there's nothing really remarkable about that variability. It looks like it was just the seasonal variation of the ionosphere causing that. Blast! So my attempt to try and use explosions to wheedle out the signature of bombing appeared to have stalled. So I thought, well, I need to find some other data. And what I really needed to do was know the times of the bombing raids on London. And so I looked in the university directory. We have professors of modern history. I sent Patrick an email. And Patrick said, well, we don't really know that much about the Blitz because we destroyed a lot of the records. And also the German aircraft were not capable of carrying such big bombs. But I'm studying the bombing of Berlin, and I can tell you the Allied aircraft carried much more munitions. So at this point, we started to collaborate, and I was able to use Patrick's historical data to try and inform my research. I shall hand you back to Patrick to tell you a bit more.
So I'll pick up back in 1940, because I think one of the points I was making was that the tonnages of bombs which were hitting the Germans were vastly greater than anything, but not immediately. I mean, just this afternoon I've been looking through the papers of Lord Portal, who was the Chief of Staff of the Air Staff, covering the entire World War II. It was like going through 1939, 1940, right through to 1945. And you got a real sense of the problems that Bomber Command had of really doing anything in the early years. Whereas by the end, it's as if they've developed overkill, that they don't know when to stop. But I think what's interesting is that the Blitz, which the Germans start, initially seems to have happened almost by accident when bombs were dropped on central London, on the East End, on the 24th of August 1940 against Führer orders. But then immediately, looking at the Churchill papers, there was a desire to have retaliation. He was kind of waiting for an opportunity. But initially, the planes which were flying to Berlin, this is a Whitley 2-engine bomber, which could not really drop a particularly heavy load. It was also very prone to mechanical failings. We're dealing with twin-engine planes right through till at least 1942. And initially, a lot of what's going on also is dropping leaflets. There's a propaganda war, which later on Arthur Harris is completely dismissive about, and says that anybody who picks up a leaflet must be a moron. Why are we doing this? But it started in kind of smaller incremental stages. But I've been looking at some of the first reports which the RAF made of that first mission, and in many ways I admire the ones who went in August 1940 in what was atrocious weather in these quite tiny planes at the very limit of their range. And they're reporting that, we hit the Siemens and Halske, electronic works. We think we hit, one of the railway stations. And then if you look at the German reports on the ground from the Hauptluftschutzstelle, they say, well, they hit an allotment in the northeast of Berlin. And the joke went around Berlin that now the British are trying to starve us out. So it started off as, really nuisance raids. This was the word which was used internally, part of a war of nerves. And a lot of these initial planes, didn't actually make it back and were crashing in the North Sea before they returned. So let me just... So it really takes a new type of aeroplane to actually deliver the tonnages. It's the Lancaster bomber, which only really comes into service in 1942, and it's only in 1943 that it starts hitting some of the targets which Arthur Harris is trying to hit, like the Ruhr and like Berlin. But I think this is where, if you go to the archives in Kew, you'll actually see some of the crossover, some of the names that Chris has been talking about with this radio research station at Slough. This is Edward Appleton, who was investigating the ionosphere and then got the Nobel Prize for Physics in 1947. This was his colleague or rival, I'm not quite sure. They had a bit of an argument about who developed radar. But clearly the RAF had a huge interest in this type of electronic science that was going on in terms of navigation. So one of the really big problems for the RAF was actually finding targets at all. Just reading one of these reports where Churchill is getting the report saying that only about 30% or 20% of our bombs are coming even within 5 miles of the target. And he says, this is a really serious report, we've got to do something about it. So they use science. This is Bernard Lovell, who you may know as the founder of Jodrell Bank, which was a kind of radio astronomy station. But back in 1942, he was part of a team working for the RAF to develop what was called H2S, which was air-to-ground radar. And if you look at this Lancaster bomber here, just this bit here is a pod which had its very beginnings of electronic warfare, where planes could just about get some sort of image of what was down on the ground. So what you see here is what this H2S would have looked like on the oscilloscope. And this is Berlin. And this, if you look carefully, if you know Berlin, this is the Wannsee. And if you look at this, hope you can see this. I'm afraid this is my rather amateur photography from the National Archives. But these are what the RAF would do would drop something called a photo flash, which would go down and take a photograph of the ground. And then they could plot with their maps of the ground where they thought most of their bombs had actually fallen. And here you see the Wannsee, so you can recognize it, but you have to have quite a lot of experience and doing this flying at speed and when you might be being attacked at the same time. It was a distinct art. The first big raid on Berlin in the middle of January 1943 is this one. So here you see Berlin, but can you see that without this artificial aid, they're completely missing the city. The Germans built decoys, set up fires, deliberately trying to put the bomber crews off. So they were still notoriously inaccurate, even with the Lancasters going in. But this is from the 1st of March 1943, and you can see that these are the southwestern districts, so where I was living, Schöneberg is about here. They really are beginning to hit the city, and the Germans really realized that. You see in the diaries of Goebbels, who was, as well as propaganda minister, he was the Gauleiter of Berlin and in charge of aerial defense. And he says, right, we've got a serious problem now. So this is the Lancaster. I think you've been hearing from Chris that he was interested in kind of numbers. He was interested in lightning and kind of artificial explosions. I mean, what you'll hear a bit more about later on is this particular bomb, which is the cookie. When I read out the description of the Japanese ambassador about the single bomb which landed 2 meters away from the embassy, it was one of these, which essentially destroyed the entire building. And it was only the Lancaster which could carry this, as well as the Mosquito. Amazingly, it could get one of those inside it. But what you see here are the incendiary bombs, which were what were doing the real damage by burning buildings out. So the cookie would go down, it would cause a huge pressure wave, it would blow out windows, it would blow the roof tiles off buildings, and then the incendiaries would fall through the roof spaces and, in theory, and as happened at Dresden, start a self-feeding fire, a firestorm. Now, what we wanted to show you a little bit of is that there has been some recreation or attempt by the BBC to do a virtual experience of the bombing, where they took a sound recording from the BBC archive, and I always like to plug the BBC because it has its archive here in Reading. But one of the most famous broadcasts in the war was from the 3rd of September 1943, where Winfried Vaughan Thomas, you can see here, with his sound recordist Reg Pidsley, went along with their recording equipment, which was kind of pretty primitive, and you'll see on the BBC's reconstruction, somebody huddled over what looks like a record player. That's his recording, he's cutting the sound. And what the BBC have done is then put a kind of computer simulation, which is virtual reality. And we did toy with the idea of actually putting on a headset and, perhaps giving it to the Vice-Chancellor to wear. But we decided, against, it was too much technology. But what you'll see is essentially just a film. It's a YouTube film, but the crucial bit of the raid where they're just coming up to Berlin. So this is where you may get a sense, but certainly the sound is authentic. Now, can we kill the lights, or do I need to kill the lights? Oh, it's like magic. I wish all my lectures were like this.
The first thing we can see now is a wall of searchlights. Not the dozens as we saw as we came into the coast, but they're in hundreds. It's a wall like with very few breaks. Behind that wall is a pool of fiercer light. It's glowing red and green and blue. And over that pool, hundreds of flares hanging in the sky. That's the city itself. There in the heart of the glow, there is a bigger red flash, the biggest we've yet seen. That must be the first of the big 400,000-pound bombs going down. Black coming up at us now. That one went down, and it's pretty near to me. Our aircraft rocked. So we're running straight into the most gigantic display of fireworks in the world. We're due over our target. We're 2 minutes' time, and below, our bomb aimer is forward. He's lying prone over his bomb site. And the searchlights are coming nearer now all the time. There's one cone split again, and then it comes together. They seem to spray out at first like the tentacles of an octopus waiting to catch you. And this time, as they come together, they've got a Lancaster right in the center. It's up to us. It's getting too hot for these searchlights, and we're starting weaving. Our pilot put the nose of the lamp down, and we're tilting away a furious angle. Up comes our starboard wing. Let's kill that Lancaster now.
Okay, boys, okay. Hello, Bombardier. Okay, when you are. Bombardier, over here. Right.
keep weaving, Sam. Steady. Right, a little bit. Bob, going in a minute, Bob. 1, 2, 3. Bob, still going. And Jenny, wait a minute, Bob. Where is he, Red John? Down! Now, he's come down. He's down. Did you shoot it down? Yeah, he's got it, boy. Right now. Keep waving. The light coming at me. Okay, show one. Alright. Okay, put it down, Tiger. Alice, well, we're turn on to 081. Right, 081 navigator. Turn on the speaker one, snappy boys, okay. Okay. How do you, Mr. Did you recognize that fight you want off? No, I didn't recognize it, but it's definitely going down now. Good, Jimmy, I can see it, boys. Good show. I can see it now. I'll tell you it's burning. Have you got something? Good show, lads. Now keep your eye on that one. Okay. Now, lads. And so we're putting some snap on, Skipper.
Right. So, I think it's pretty interesting what interactive VR technology can do there. So that's the thanks to the BBC. I think what saved them from that night fighter that attacked was that they just released this cookie, this 4,000-pound bomb. And as Reg Pidsley, the sound recordist, said, it was like going up in a lift, 20 stories. And this just sort of put the German off. But here you see, this is the cookie. This is the regular standard size 4,000-pound one. But in January 1943, the RAF dropped a few of these, the 8,000-pound, which was 2 of these bolted together. And if you really wanted to, you could have the 12,000-pound high-capacity bomb. And certainly reading some of the accounts of the Germans on the ground, sometimes these things didn't go off. They were not at all aerodynamic until they started putting these things on, but they would just sort of land on the side. But imagine defusing one of these things. But the other thing we should remember is that actually the SS forced large numbers of concentration camp inmates to form what were called Baubrigaden, building brigades, and they were the ones who had to do some of the really kind of dirty work of pulling the bodies out and clearing up after the raids. But we got quite interested. What I understood from Chris was that he wanted numbers, he wanted times, which the RAF and the Germans were very good at doing, and we could kind of compare them with each other. But also there were sometimes specific mentions of these cookies going down. So this is Berlin, this is Mariendorf, which is in the south of the south centre near Tempelhof. But you can see this is where one of these has landed. So next to a row, you can see it perhaps a bit better here, it's landed around about here, but these are the ones which are going to have to be demolished, this sort of set of buildings. And so this is probably about 100, 200 metres across. I mean, I have been in contact with some kind of medical experts about what the survivability of, being close to a cookie. And there was a certain level where just the sort of sheer speed of the pressure wave would have just gone through your chest wall and disintegrated your lungs. So you just had no, chance really of surviving. But we did seem to have something that potentially could be used to start measuring a kind of artificial lightning coming from the Blitz on Berlin. So.
Thanks, Patrick. Well, I grew up on the south coast, and it came as quite a surprise to me. My father is in the front row here. He's helped me look up for some of these timings as well. But it came to me as quite a surprise that the first Grand Slam bomb, the 22,000-pound bomb you saw at the top of that stack of big bombs, was dropped in the New Forest. And evidently it shook the ground for miles around. And it created this crater, which was 130 feet across and 70 feet deep. And next to it is the crater from a tall boy. So that's one of the slightly smaller of these bombs, which were designed to actually penetrate the concrete armament around U-boat pens and things like that. Well, this crater is long gone. It's been filled in, but the tall boy crater is still there. You can go to the New Forest, and there's a postcard you can buy of a pony sort of just having a little drink at the edge of this lake, but it's suspiciously circular. And what I wanted to know, what these provided me with was a very well calibrated experiment. It's a grim experiment, but it's a very well calibrated experiment. This is from the firing ranges at Aberdeen, where they were testing these cookies, trying to work out what the blast radius was, how to make sure that the blast went in the right direction, how you could get the maximum effect out of your explosives. And it was filmed from various different angles. And you can see the pressure wave here coming towards you across the ground. Not only that, but the actual fragments of these bombs would be propelled at great speed. You can see in this shot here. So the shrapnel was devastating as well. But it actually was just that shock wave, which is the thing that I was interested in understanding, because that not only you can see it on the ground in this movie, you can see it moving across the ground here. But that's the ground signature of a shock wave that's traveling in all directions. And the reason that I'm interested particularly in these cookies is that the explosive energy of one of these is about the same explosive energy as a lightning bolt. So here's a very slow motion film here of the electrical pathway trying to be made to the ground, many opportunities. Don't know which one's going to be. That one arrives first and the current flows back. But that big flash, it's different from an explosion. It's spread over a range of altitude, but it does contain the same sort of energy. So if you can detect one of these in the ionosphere, then that gives you hope for understanding how natural phenomena such as thunderstorms might be able to affect it too. So as Patrick said, we now have all this information to actually start to reconstruct our experiment in the past. We have very detailed logs of this, for example, is a book that was written which has appendices which detail the timing of the air raid sirens that went off at Berlin, and estimates of the numbers of planes and estimates of the numbers of bombs. And the author from this report probably got a lot of this information from the archives at Kew. And Patrick, you said that he ended up being in prison because he was working for...
He was the good one.
He was the good one.
His colleague who was in the Stasi.
Okay, right. I don't want to malign him then, yeah. So, yes, but so this data may have been compiled with an agenda, but nevertheless it's very useful to be able to say, okay, these are the times that the bombing raids happened, and the RAF kept impeccable records. They've been summarised in this book here, the Bomber Command War Diaries, which show you what nights, what raids were happening, but and how many planes and what type of planes. But you have to go into the archives, as Patrick has done here. This is the sheet from the Dresden raid, and you can see the targets, and you can see the planes, and you can see whether they felt that they were successful or whether the aircraft was missing. And this is the number of bombs. You can see the munitions in there. So we're starting to build up the information we need to do this experiment, this rather macabre experiment. Well, what would we expect to find? And how do we, I've already told you that the sun is varying and it's creating all these wobbles in the ionosphere. So how do we tease out the signal from below? Well, if you imagine this is our FOF2 trace, so this is the strength of the ionosphere, and it has all these wobbles in it over time. But now we know when there were some bombing raids. So here are the bombing raids. We know that those happen. And we can do what a physicist would call you take a range of times around those to see if there's any effect in a sort of delayed time. But we can now do what a physicist would call a superposed epoch analysis, because it sounds rather grand. But actually, a meteorologist would call it a composite analysis, where you average all these bombing times together, and they would all line up. I'm afraid I've got my axis rather shifted, but the 0 should be there. And if you have a small but repeatable signal, if you add them all up, that should amplify itself. But if it's just random, sometimes the signal is positive, sometimes it's negative, because it has nothing to do with the bombing raids, then those should cancel out to nothing. So you should get nothing around it and a signal in the middle. So I did this for the data from the radio research station at Slough for about 500 raids between 1942 and 43. And we were able to reproduce this study. But of course, if you're taking an average value, you can also make an estimate of what the range of those values were, and that tells you how noisy your signal is. You can also repeat the experiment 100 times or 1,000 times using times when you know there wasn't a bombing raid, just to see if this would happen by chance. And by looking at the range of those measurements, you can see whether it's actually within the bounds of normal chance anyway. So it needs to come outside of those bounds for it to be significant. And this is what we got. So this is the FOF2 values. This is our time 0, and we've added up, this is the number of raids. So all of the raids occur at time 0, but because obviously the RAF didn't know that 70 years later, here I am doing an experiment, they also included quite a bit of noise by doing bombing raids on the days around the days that I'm interested in. So some of the variability here and here might be because there are still some bombing raids going on, but where all of the bombing raids are concentrated, you can see that the strength of this signal is very much depleted. In fact, there's less than a 1% chance that that has occurred by chance. So that was an astonishing result, to me anyway, that you had raids going on over Berlin, over all the major cities, and there's sort of Cologne and Hamburg. These are all part of the study. And scientists at the Radio Research Station in Slough were able to measure the impact of these bombing raids in the ionosphere in space, 250 kilometers above their laboratory at Ditton Park. And what we think is happening is that the shock waves generated by these bombs, because remember, it's not like a lightning stroke, there's no electrical signal that you'd expect, so it must be some sort of shock wave. As these waves propagate up through the atmosphere, they travel up through the atmosphere gets thinner and thinner as you go up, so that energy gets shared out between fewer and fewer particles, and so the wave gets bigger and bigger and bigger. And then just like a wave coming in and crashing against a beach, the wave breaks in the upper atmosphere and deposits all that energy as heat. Now we know that the chemical reactions that go on to maintain this ionization in our upper atmosphere are temperature dependent. So if you increase the temperature slightly, then you increase the rate at which the ionization is lost. And so it's entirely consistent that what you'd expect is if you have these bombs which are generating heat in the upper atmosphere, that it weakens the signal. So there we are. Patrick and I were able to combine our resources and produce an experiment in the past. But can we say anything about how much explosives do you need? So I divided the raids up here, and this is the tonnage of bombs. Goes anything from 100 all the way up to 1,000 and greater. And this is, the measurements at Slough were made at noon. They were made at noon each day, so it's a daily measurement. How many hours before noon is the best time to do your raid if you want to detect it? So this colour scheme here is how wobbly the ionosphere got. It's how big that minimum dip was. So the graph I showed you is from here, this white spot here. This is the sweet spot. So for about 5 hours before, if you do a bombing raid, it takes about 5 hours for that energy to propagate up and break the waves to break and to generate the heat and for it to influence the ionosphere. But you can see that we haven't actually found the smallest number of bombs yet. Even though if you go down to sort of 100 tons worth, you can still, although this is the minimum, so it still has some big raids in here, we haven't actually been able to find a minimum bombing tonnage that we can break out of the data. So that's the next thing, is we need to start looking at smaller and smaller raids. I kind of went in big thinking that's what would be needed, but I think actually some of the smaller raids involving the Mosquito aircraft, if we can find those that are separated out, we might actually be able to find that we could see those too. So there we are, an experiment that's born out of interdisciplinarity. Oh, I managed to say it this time. So we have shown that we have intense bombs and they create shock waves that had a measurable effect on the ionosphere. And we were able to do this because we still have accurate records to determine how much energy is required to have that effect. So we had the number of planes, the number of bombs, the type of explosives, the size of those bombs. So we actually have quite a well-controlled experiment. So now we can start to compare that with the impact of natural phenomena such as thunderstorms and volcanoes on the ionosphere, and maybe start to understand that variability in a bit more detail. And that's really useful for us because a lot of our modern technology actually still relies on the ionosphere. We still use radio communication to broadcast and communicate around the world. But we now have things like GPS. And the GPS satellite signals, as they come down through the ionosphere, if the ionosphere is disturbed, that can deflect those GPS signals and reduce the sensitivity of and increase the error in our GPS signals. So understanding the wobbliness of the ionosphere is something that this experiment is really helping. But as Patrick mentioned, we did quite a bit of media work when this paper was released, because it contains a lot of things that people are interested in. It has space, it has bombs, and Nazis. But I've never before been anybody's muse, unfortunately, until today. And Patrick and I are very grateful to Sam Illingworth, who is a science communicator who was so taken by our work that he was moved to write a poem about it. No one's ever written a poem about my science before now. Maybe the odd smutty limerick, but nothing repeatable. And we asked Sam if he could come here tonight to read us his poem. Unfortunately, he's unavailable. He's at a meeting in Manchester, but he did record it for us. So I'd just like to end with how Sam interpreted this work.
A blemish in our atmosphere. Between the curves where space and sky entwine, the air is stripped by violent solar flow, a savagery inherently benign when matched with what arises from below. The shockwaves of our past can still be felt, revealing every blow as it was dealt, as ripples found in time reveal each scar. The atmosphere cannot hide what we are. I was inspired to write this poem not just by the poignancy of the topic, but also by the interdisciplinarity of the approach, with Patrick and Chris exploring the liminal spaces between their two disciplines to ultimately create something that would not have been possible by one scholar working independently.
Thank you, Sam. Your check's in the post. Thank you very much.
I think we can all agree this was not only one of the most unusual lectures, I think, that will have been those who come regular, but I think also one of the most fascinating. And please join me in thanking both our speakers for what's been incredibly diverse exploration of the liminal spaces, not just between Earth and the sky, but also between the disciplines.
Thank you. We also just thank the events team who did lots of the organisation for this too.
We have 25 minutes roughly for questions, and so could I just ask you we have two microphones roving around the lecture theatre. If we might ask you to raise your hands, and we might just collect a few, so you can select which ones you want to follow up on and avoid the really difficult one.
There's somebody there.
Somebody over here.
welcome. I wondered whether you had any data from when we did atomic bomb testing, because obviously the tonnage there is so huge. The effects on the ionosphere must have been catastrophic for some time.
Yes, thank you. So actually, a lot of experiments were done in the 1950s during the tests that were being done then, and it was billed as a marvelous opportunity to conduct an experiment in the ionosphere. They were quite gung-ho about detonating nuclear bombs at 30-kilometre altitudes. But it did make me think, because I think that's a question that did come up when we did the paper. What measurements? There weren't very many ionospheric stations around the world in the 1940s, but in 1945 there were some in Canada, there were some in Australia, and there were some in Japan. And so I asked a Japanese colleague of mine to provide us with the Japanese data. And unlike Slough, which had this state-of-the-art recording on film, they were actually drawing out graphs by hand. They were taking the pulse and drawing them by hand and then annotating them. And after the Hiroshima bomb was dropped, the ionosphere looked perfectly calm beforehand, and afterwards it's just a mess. So it's very difficult to know with just one sounding. Was there some solar event that could be blamed for that? But what I hope to do is to try and, using the 1950s tests, they tracked the shockwave around the world, and I'm hoping to see if I can estimate from the speed of those shockwaves when you would expect to see it in Canada and in Australia, and check to see if there's any signature of the Hiroshima bombs then too. So yeah, it's another opportunity to have a look. But you're right in saying that they had a lasting effect. The effects of the atomic testing lasted for 20 years in the ionosphere after, well, certainly in the atmosphere after the original tests were made.
That's a question in the penultimate row, yes.
Hello there. If Dresden was to happen all over again, do you think you would find different results because of climate change?
Ooh, that's a good question. I don't think so. The sort of impact that these shockwaves had, they lasted for a few hours, and the temperature of the upper atmosphere is responding to climate change. In fact, it's getting cooler, the upper atmosphere, because the heat's all being trapped in the lower atmosphere. But those changes are quite subtle and very long term. So you would still see the signature of a temperature change, even if it was from a different baseline temperature.
Hi, my name is Paul Timpley. Actually, this has got a sort of connotation, family connections to me. My late father, who died in 2007, was a Lancaster bomber pilot in 42 and 43, serving in a Pathfinder squadron. He was involved at the age of 21 in the firebombing of Dresden, and also in the bombing of the Ruhr and Berlin. So the connection is this. This is not a moral debate, it's a debate on science and the history of the bombing. And I had many conversations with my late father, who subsequently joined CND, Campaign for Nuclear Disarmament. But my question is aimed at the academic, the historian academic, and I'm particularly interested in his introduction, where he suggested, in fact also stated, that Churchill himself, it was a mistake by the German Luftwaffe, who took a further bombing raid by going one loop up the Thames and dropping above Rotherhithe, that initiated and gave Churchill the excuse to start the bombing war and the Blitz on Germany. That was stated by yourself. Apologies if I got that wrong. That's the way I've always understood it, having read many documents on the subject. I don't want to obviously comment on the moral situation, but can you just confirm that it did appear that Churchill was very keen to start a full campaign of aerial civilian bombing on German cities, and that the Germans actually didn't want to start that at that stage in London at that point? Thank you.
Yeah, I would say that, what you find in the archives is back in about July 1940, Churchill is saying, if they hit London, we need to be ready to hit Berlin. So Berlin in particular is quite a political target. They're aware that they can't do the same amount of damage, but they want to create a kind of psychological shock. So then they hit Berlin the next night, and after that, Hitler and the leadership say, right, we're now going to sort of, no holds barred against London. So the 7th of September, which you were pointing to, is the beginning of that, very intensive period. And what you see looking at the diaries of people like Goebbels is, jubilation really that this is potentially going to take Britain out of the war. And all that the RAF can really do is, symbolic acts of resistance just to show that they can reach Berlin. But if you look at the papers, and I was just seeing one of these today from Churchill from about 1942, where he's saying, well, I don't think bombing's really going to win the war. This is the claim which Arthur Harris is making, that they can just end the war and avoid all of the ground fighting. So Churchill seems to be being, a little bit, having it both ways, really. But when it comes to bombing Berlin, it's very much Churchill who's doing this. What he's doing is he's having a meeting with Stalin in August 1942 in Moscow, and then he's telegraphing back saying, what can we do? Because I'm getting this pressure that we're not starting a second front. The Russians want to see some sort of action. So then he's putting this pressure to try and hit places like Berlin. And what Bomber Command are doing is saying, we can't do that yet. But there is an internal debate at the very top leadership of the RAF about whether they should really be hitting things like oil refineries, marshalling yards, transport targets. And Arthur Harris is absolutely fixated on hitting these cities. And I think there's a big question mark over what it was really doing, apart from obliterating some of these cities and causing an awful lot of suffering to German civilians. But I've also looked at the what are called the Home Intelligence reports for British public opinion at the time. And what you see is that most Brits think, okay, they hit us in 1940, it's kind of payback time. But there are some differences, particularly in the regions like Coventry and Hull have been really badly hit. They're the least likely to say that we should pay back with bombing. It's usually the areas which haven't experienced bombing at all that are most gung-ho about it. But you're right that you mentioned at the end, Churchill tries to, after the Dresden raid, he realizes that the media are becoming potentially hostile about it. And he puts in a memorandum which talks about wanton destruction, terror, he uses the word terror bombing. And the RAF leadership have a mini kind of meltdown, and they insist on rewording this so that terror gets taken out. So there's a minute that goes in the end of March 1945. But what you see in the days after that is they stop area bombing. And so I think you might argue it's too late. But there's this constant kind of dialogue with the Americans who are doing the daylight bombing and suffering horrendous casualties at the beginning themselves to try and hit things like ball-bearing factories and oil targets. So, you're right that of the 125,000 RAF bomber crew, 55,000 die. Those casualties are horrendously high. It's the worst casualties in the British Armed Forces, by a mile. So what it took to actually get in those planes and, go on those missions The plane that we showed in the reconstruction F for Freddy, most of that crew did survive, but the plane itself was shot down, I think on the 4th of January 1944 over Stettin, with everybody lost. So doing those bombing missions was incredibly dangerous, especially at the limit, places like Berlin.
Thank you. Regarding Churchill's keenness to switch to bombing cities, I've read several accounts which suggest that it was motivated largely by a desire to encourage the Germans to switch to bombing our cities from bombing the airfields from which our fighters were preventing the possibility of a German invasion by sea, providing air cover over the channel. Would you think that there's significance in that?
Well, I haven't found a kind of smoking gun, exactly to that effect. But I think that the RAF are relieved in many ways that it is taking the pressure off, all of these air bases in the south of England. But I think at that stage it's quite kind of one-way traffic, that the Germans are dropping, maybe 10 times as much on places like London as the RAF is able to do back in 1940-41. But I wouldn't be able, I don't know, I wouldn't be able to say definitively, whether he was kind of that Machiavellian. But he's clearly thinking about the kind of political psychological effect of bombing the other capital. Because what the RAF want to do at that stage is they think it's a bit of a waste of time, with their few resources anyway, what can they really achieve? But they do try in those early years to try and hit oil and transportation and, if you like, the military targets. But I think even the leadership, Portal, who comes in October 1940, realizes that they're just not hitting these things, that it's almost like wasting their bombs and they're getting shot down in the process. So Portal is actually one of the first to start talking about hitting civilians. But the other person who keeps coming into the mix is Lord Cherwell, who was the scientific advisor of Winston Churchill. And he comes up with ideas about incendiary bombings and dehousing civilians. So what you see is Cherwell sends a memo to Churchill. Churchill says, what do you think about this as an idea? The RAF realise that they're in danger of making themselves look silly by not hitting anything. So they start moving towards hitting cities as a policy. Late 1941 and then beginning of 1942, it's kind of enshrined as policy. But what you'll also see is that what the British public are hearing about this in the broadcasts is always that it's an industrial city, or that they're hitting the industrial areas of the cities. And there's a very interesting correspondence from Arthur Harris in October 1943, where he says, look, let's just be straight with the public, because this is going to cause us problems afterwards if we're found out. And so he is saying we should say that we're aiming at civilians, civilian workers, and we're trying to kill them. And the RAF leadership say, oh, we can't have this as official policy. And there's a real kind of mini panic at the end of 1943. And essentially he is ordered to toe the line that the RAF is still, even area bombing is still industrial bombing. But what you can see is that they're always looking over their shoulder at the Americans and thinking that the Americans are getting better publicity than them. And Portal, as the head of the Chief of the Air Staff, is desperately trying to push Harris towards hitting things like oil targets at the end of 1944. But it's bordering on insubordination that Harris just keeps hitting the cities. And in the internal documents, you hear heads of the RAF talking about he is obsessed. You know, some of them are talking about whether he should be, you know, asked to, you know, take the consequences. But they realise that he's a kind of force of nature, and that he's actually quite, you know, popular in the RAF for being this kind of brutal leader. But it's, you know, it's a very interesting story about the politics of what's happening at the top.
There's one more there in the middle.
Obviously the bombing from Americans and the British did a huge amount of damage, caused a huge amount of casualties. Did it actually really hit the morale of the German people in the latter stages of the war?
Yeah, well, they have various theories that if you bomb a little bit, it kind of creates a kind of angry reaction. That if you bomb repeatedly, you get to a point of, they talk about apathy, resignation. But I've been through all of what with the Joint Intelligence Committee was the sort of apex of the intelligence community. And what you see is that bombing increasingly just becomes kind of a routine item on the agenda. And they sort of see, they seem to be mainly interested in the military targets on the Joint Intelligence Committee, what's being hit, but they will always have an item on morale. It's clear also that SIS, the MI6, did have some agents on the ground in Germany, and you know, occasionally reports will end up on Churchill's desk talking about the kind of grumbling and anger that's going on the ground. But what all of them agree is that there are no ingredients for a kind of insurrection. What they're looking at is in Italy, some case could be made that by the middle of 1943, Italians had had enough of the much lesser bombing that they'd suffered, but it was much more incompetently handled by the Italian authorities. So they talk about bombing Italy out of the war in mid-1943. But even though you might think, okay, maybe they think they can do this in Germany again, I think it's only Arthur Harris and a few others around him who seriously think that morale can be the final kind of straw that's going to break the camel's back. They think a bit about foreign workers. There are 7 million forced foreign workers in Germany by 1944, whether they could become the kind of kernel of an insurrection. But what we see from the kind of memoirs about them is that there was so much guarding of these people, and that what they tended to do was to try to help clear up. That was their natural human instinct after a raid, was to, you know, in one case, concentration camp inmates dug out the wife and children of the local party man in the town. And there was this kind of weird scene where he sort of thanks them for saving his wife and kids, and they're in their concentration camp gear. So I think the bombing, what it seems to have done is to push the German population, ironically, closer to the party regime. And Goebbels was, in some ways, you know, grateful that he had this opportunity to step up now and play the great kind of saviour. And that's what's caused this huge debate, which erupted about 10, 15 years ago, about the Germans seeing themselves as the victims of the Second World War, like other groups. And bombing was absolutely key to that. So Goebbels is saying that that's all they're talking about is bombing, but it doesn't change it doesn't end the regime. It causes a lot of suffering, and it allows the party to pose as the saviour.
Thank you.
I think we've come to the end of I think that's been a very interesting evening. I'm sure there'll be some chances for some of the remaining questions maybe to sort of speak to the two speakers individually afterwards. And before I ask you to join me again in thanking both Chris and Patrick, let me pitch the next lecture in 3 weeks' time, which will be Flora Samuels talking about Britain's housing crisis, designing future homes and cities, on the 20th of March. I hope we're going to see many of you and can welcome many of you again here for that at the same time on the 20th of March. But please join me in thanking Patrick and Chris again for what has been a fascinating evening.